Hi, and welcome to TEMEKO. In this video, we will take a look at the concept of linear impulse and momentum. During the video, we are going to learn their definition and also how they are related. Let's get started. If you haven't heard the words impulse and momentum previously, don't worry. They will be explained now. To understand their meaning and their relation, it's better if we use an example to help us understand this concept well. Think about if we want to have a box which is resting on the ground. Because it's resting, it wouldn't have any motion naturally. However, we don't want it to be resting but moving instead. So what should we do in this case? Yes, you guessed it right. We should introduce a force to the box which compels it to accelerate, and thus to move like it's also dictated in Newton's second law. From this law, we can notice that the acceleration which the box will experience is related to its mass m. On the other hand, we can also notice that in addition to the dependency of inertia, the gained acceleration will be dependent on the force and also the amount of time at which the force is applied. We call this dependency between the magnitude of the force and the amount of time as an impulse. If we want to arrange the terms in Newton's second law and integrate both sides between the initial and end limits, we end up with the following expression. From this equation, it's quite clear that the final velocity of the box, v2, is dependent on the magnitude of impulse, which is determined from the left side integration in this equation. Therefore, the box's total rate of change in momentum, which is the product of its mass and the difference in its initial and final velocity, is also affected by the resultant force that is acting on it in a certain time interval. This concept is what we call the principle of linear impulse and momentum. It's good to notice that if there are no applying external forces acting on the closed system, like in our box, then the total linear momentum doesn't change but would remain the same. Now that we understand what is meant by linear impulse and momentum and what their relationship is, let's go through some more specific details about them. As we have covered, linear momentum is the product of the mass and velocity of an object. The SI unit which we use for linear momentum is kilograms times meters per second. Notice that momentum is a vector of which the direction is the same as the velocity vector of the object. Why, you may ask? It's because of the mass of the object, which relates the momentum and velocity together. Because the mass is a positive scalar, the directions of both vectors are going to be the same. In case of an impulse, we have learned that it is a quantity, and more precisely a vector quantity which measures the total effect of the force which is applied on the object during a certain time interval. If the magnitude of the applied force varies, then we have to determine the magnitude of the impulse by means of integration, as was previously explained. We can also represent this magnitude of the impulse caused by the variable force as a shaded area under the curve of force, that is, function of time, as is shown here. In situations where the applied force remains constant while it's applied, determining the magnitude of the impulse gets much easier for us because we don't have to use an integration to solve its magnitude. Instead, we can use the following simple equation in order to solve it. It is possible for us to represent the magnitude of the impulse due to the applied constant force with a rectangular area as is shown here. Hopefully, by watching this video, you have a better understanding of the principle of linear impulse and momentum. You are also aware of the specific details related to linear impulse and momentum. Thanks for watching and have a nice day.